Students, how are you and how was your day? Tonight we'll be talking about complex numbers. I know very well that we stopped at powers of I, so I'm going to solve one or two examples before we proceed. Is that clear? Okay. Yeah. Before we proceed, I'm going to before we proceed, I think we stopped at powers of i's, complex numbers. So we'll look at one or two examples before we proceed further. Complex numbers, Mth311, complex numbers. Amen. Okay. So we stopped at powers of I, right? And we're able to solve one example in class. So tonight we are going to solve more examples. Is that clear? Please don't forget to enter the attendance. Is very important. Attendance is very, very important. Is that clear? We'll look at powers of I. Is that clear? Yeah, sorry for the break in transmission. We'll be looking at powers of I. The other day, I said if we are asked to evaluate I raised to power 4, we looked at it this way, two of us. We write solution. We now recall that I raised to the powers, that is I is equals to square root of minus 1. So when you take square roots on both sides, it means this I square will now be equals to minus 1. Amen? True or false? So this implies that I square is always minus 1. Please take note. So now, if you are asked to evaluate I raised to the powers of 4, this means that, this implies that you now apply indices. If we have I raised to the powers of 4, in indices, this is the same thing as I times I times I times I into 4 places. So now we can reduce this into this form. I dot I, that is I times I, is the same thing as I square, then times I times I is I squared. True or false? Now we now recall that I squared is always equals to minus 1. So this is equals to, here is minus 1 times here is minus 1. Amen? Then this will equals minus times minus plus. Then 1 times 1 is 1. So this implies that I raised to power 4 is 1. Is that clear? Any question? Do you have any question that you want to ask? Do you have any question that you want to ask? If you have any question, please. Any question? Any question? No question. Okay, so we can proceed, right? We can proceed. Like I think we did. So let's consider if you are asked to evaluate I raised to the power of 12, or we can write solution, right? So I raised to power 12 is equals to I, let's break it down for the sake of millions. Amen. I dot I dot I dot I dot I dot I 1, 2, 3, 4, 5, 6 times I times I times I times I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times I 11, 12. Right? Okay. So let us reduce it into 2, 2. That is I dot I times I is I square, right? Times I times I square, right? Amen. Times I square into 6 spaces. I square times I square 1, 2, 3, 4, 5 times I square. Amen. Do you understand? You understand how we got this? Are you following? Any question? Are you following? Okay. So far, so good. So this implies that we now recall. Note that I square is equals to 1. So this will be equals to, here is minus 1 times 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 minus 1. 1, 2, 3, 4, 5, 6. Amen. So minus times minus plus 1 times 1 is 1 times minus 1 minus 1 times minus 1 plus 1 times minus 1 minus 1 times minus 1 is going to give us plus 1. It implies that I raised to the power 12 is 1. Any question? Any question before we proceed further? Do you have any question? Yes or no? Please, if you have any question, drop it in the comment section. Let me attend to you before we proceed. Any question? No question? So we can proceed, right? Can we proceed? Yes or no, please? Can we proceed? Yes or no? Can we proceed? Okay. Okay. Let us proceed. Let's proceed. Now let's look at this example. Take note of this example that I want to solve because you may see it in the exam. Very important. Okay. Prove that I raised to the power 3, open brackets, 1 plus I, then plus, open bracket, I raised to power 5, I raised to power 5, I raised to power 5, open bracket 3, 2 plus I. 2 plus I equals to 3. Yeah, it's a very good question that you may likely see in your exam. So please take note of this question. It's very important. Very, very important. Take note of this question. Take note. Okay. So let us proceed to solve this problem. Let's proceed to solve this problem. Okay. That is, this question says prove that this left hand side should be equals to the right hand side. And the right hand side, what do we have? 3. So let us prove whether at the end of the day we are going to have 3. Okay? So let's write solution. That is I raised to power 3, open bracket 1 plus I, close bracket plus I raised to power 5, open bracket 3 minus I, plus I raised to power 7, open bracket 2 plus I equals to 3. Amen? Okay? So far, so good. So let us apply the powers of I. So you know very well that I cube is equals to I times I times I, where this is the same thing as I squared times I. True or false? So I squared is minus 1 times I is equals to minus I. So it implies that I cube is equals to minus I. Are you following? Okay? Then, let's break it down. I raised to the power 5 is equals to I times I times I times I times I, right? Amen? Amen. Okay? So this is equals to I square. Let us reduce it in the form I square times I. True or false? True or false? Any question? Please, do you have any question? Any question? Yes or no? Do you have any question at this point? No question. It means we can proceed, right? We can proceed, right? Yes or no? No question? Okay? So let us proceed. So here, minus 1 times minus 1 times I, minus times minus, plus 1 times 1 times I is I. Then, let us talk about I raised to the power 7. Then, this is I raised to the power 7. Let us simplify it. I times I times I times I times I. 1, 2, 3, 4, 5 times I times I. 6, 7, right? So let us reduce it. This is equals to I raised to the power 2 times I raised to the power 2. This times this times this, times I raised to the power 2 times I. Amen? Do you agree with me? Am I right? We applied indices here. True or false? Hope I'm right. Am I right? Yes or no? Hope you are following. Okay? So, what we need to do is, let us recall that I squared is minus 1 times minus 1 times minus 1 times I. Minus times minus plus times 1. 1 times 1, 1. Times minus, minus 1 times I is minus I. So let us substitute in this, and this here. So I cube is what? I cube is minus I, right? So let's write it this way, minus I, open bracket 1 plus I raised to the power 5 is I. True or false? It's true. Look at it. It's I. So let's write I, open bracket 3 minus I, then plus I raised to the power 7 is minus I. So let us not be in haste. Let us leave we know that plus times minus here will be minus, but let's just leave it, keep it like this first, for the sake of Malians, amen? So that they will not be asking unnecessary questions. Okay, do you agree with me? Do you agree with me? Any question, yes or no? No question, right? So we should continue, right? Okay, let's proceed. If there is no question, so let us open this bracket. Minus I times 1 minus I. Minus I times plus I minus I squared. True or false? What do we have here? Plus I times 3I, then plus I times minus I squared. Amen? Okay? Then plus times minus. Okay, let's do it this way. Still keep the plus sign. Then minus I times 2 minus 2I, and minus I times plus I minus I squared. This is equals to what? 3. Do you agree with me? Okay. So far so good. Minus I squared plus 3I minus I squared. Then multiply out this minus 2I minus I squared equals to 3. Any question before I proceed? Please, if you have any question, I want you to ask before I proceed further. Any question? Drop it in the comment section, please. If you have any question at this point, drop it in the comment section, please. Any question? Yes or no? No question. No question? Okay. If there is no question, we can proceed. Okay. Becky Wills said that we can proceed. No problem. Abdurrahim, no question. It's okay. Love you guys. Oh, Becky Williams, you don't understand. Supposed to be plus I. Where? Which part are you talking about? Becky, Jonathan, Jethro, Jonathan. Which part are you talking about? Where? Supposed to be. Okay, let me take it all over. Here, use this to multiply this. You are going to have minus I. True or false? Then minus I times, okay, minus times plus is minus. So I times I is going to give you I squared. Jonathan, listen up. Then plus I times 3. It will give you 3I. Jonathan, are you following? Then plus times minus is minus. I times I squared. Then plus, I said keep the plus first for the sake of Malians. Jonathan, are you following? So here we have minus I. Minus I times 2. We are going to have minus 2I. Then minus I, okay, minus times plus. We have minus. So I times I minus I squared equals to 3. Then, yeah, here is okay. I said use this plus to open this bracket. Plus times minus 2I, you are going to have minus 2I because plus times minus is minus. Plus times minus I squared, you are going to have minus I squared equals to 3. Jonathan, do you understand? So can we continue? Jonathan, yes or no? Jonathan. Okay, so let us proceed. Let's proceed. Okay, so all what we are doing, all this proving, is for us to have 3 on the note that I square is equals to minus 1. So here we are going to have minus I minus open bracket minus 1, because instead of I square we write minus 1. But note that minus will be here, plus 3I minus the same thing applicable, minus 1 minus 2I, then minus open bracket minus 1 equals to 3. Amen? Okay? So, if you can see what I am saying, so let us collect like terms, or let's do it this way first. Minus I, minus times minus, plus, right? So plus 1, plus 3I, minus times minus, plus 1, minus 2I, minus times minus, plus 1. Then this is equals to 3. Amen? Are you following? Jonathan, hope you are following. So if you can see what I am saying, let us collect like terms. That is, we make it real to be on one side, then the imaginary part, the real part and the imaginary part should be on one side. So this, they are real. So 1 plus 1 plus 1, right? The real part. Then we have minus I. Okay, let's do it this way. Plus 3I minus I minus 2I equals to 3. Yeah, true or false? Any question at this point, please? Ask your question. Any question? Yes or no? No question. No question. No question. Okay. Let's proceed. If there is no question. Okay. Profiat. Let us proceed. If there is no question, so we can have 1 plus 1, 2 plus 1, 3. Plus 3I minus I minus 2I. We are going to have minus 3I equals to 3. So you can now see that 3I minus 3 is 0. So therefore 3 equals to 3. This is how you are going to prove this type of problem question. If you have any question, please drop it in the comment section. Let me attend to you before we proceed. Any question? I give you 1 minute to ask your question. 1 minute. Any question? No question? If there is no question, let us proceed. Yes or no, please? save our time. If you have any question. Jonathan, sorry for what again? What is the problem? Ask your question. Jonathan. Sir, I don't understand. Mustafa, where? You are just coming, Mustafa. I know you are just coming. No question. I think the video will still be there, so you can still come back to it. You understand? I break everything down. Why is I, okay, I to 7 is still same with I square. Where I raised to power 7. I raised to power 7 is minus I now. Then I raised to power 2 is minus 1. Please take note. Both of them are not I. Oh, Rabiu Yusuf. How do we get 1 plus 1 plus 1 to look at it here? Look at it from here. Come here. You understand it up to this point, right? Yeah. I said note that I square is equals to minus 1. True or false? So now, anywhere you see I square in this equation, this is I square, this is I square, this is I square. True or false? So you replace it with what? Minus 1. That is why you are saying, see I square minus I square. Look at it. Instead of you, or instead of me to write I square, we replace it with, look at this bracket. What is inside? Minus 1, then plus, this is another I square minus I square. We replace it with minus 1. Then look at another I square. We replace it with minus 1. So you can now see that we use this to multiply. Minus times minus, it will give you plus. But note that we have 1 here, so plus 1. The same thing applicable here. Minus times minus is plus 1. The same thing applicable here. Minus times minus is plus 1. That is why we were able to arrive at 1, 1, 1. So we collect like terms. You know, in our first class, I tried to explain what complex number is all about. These are complex numbers, true or false? This is the real part, and here is the imaginary part, true or false? Imaginary part. Those who were in class, they know it. So we have to take the real to one side, then the imaginary to another side. Look at it. This is imaginary part. Imaginary part. This is real. Look at it. That's how we got this solution. So, any further question? Do you understand? So, we can proceed, right? Sorry, sir. I to 7 and I to 3, they are the same. Yes, of course. Ask yourself, 3 is an odd number, 7 too is an odd number. True or false? Okay, let's proceed. Let us proceed to consider. Okay, now let's consider equality of complex number. Equality complex numbers. Equality of complex numbers. Amen? Okay. What do you mean by equality of complex number? Equality is the same thing as equal. The same. Is that clear? So when we say equality of complex numbers, if we have complex numbers of this form, for example, if we have Z1 equals to A plus IB and Z2 equals to C plus ID, these complex numbers are equal. Why? Because Z1 contains real parts, true or false, and also imaginary parts. Then Z2 also contains real parts and imaginary parts. True or false? Imaginary parts. True or false? It's true. So it implies that Z2 is equals to Z2. That is, A is equals to C, then IB is equals to ID, which is this and this we cancel to give us B equals to D. So they are equal complex numbers. So assuming if you are asked to give example of equal complex numbers, at least with this example explanation, you can be able to give example. True or false? Any question? True or false? Okay. So far, so good. So let's proceed. Let us proceed. Let us proceed. So if I may ask, please write your answer in the comment section. If we have Z1 equals to IB and Z2 is equals to C plus ID, are they equal complex numbers? Please. Are they equal complex numbers? I need your answer. If they are equal complex number, justify your claim. Show otherwise, justify your claim. If they are not equal complex numbers, justify your claim. Please, I need your answer. I give you only 1 minute to do that in the comment section. I'm going to give you 1 mark. Okay, Jonathan, no, sir, because C is equals to 0 and B is equals to D. So they are not equal complex number. Thank you. Yeah, it means you are following, Jonathan. I love that. Okay, Nasiru Abdul, no, sir, because Z1 has no real part. Thank you. I love that. Any other person? Any other contribution? Okay, nobody is only 2. Out of how many students? Only 2 students. Bright Junior. Question, sir. Oh yeah, ask your question, Bright. Ask your question, please. I'm waiting for your question, please. I'm waiting for your question. Bright, ask your question, please. I'm waiting for your question. No question? Joshua? No, sir. It is unequal because C is equal to 0. It's okay? Let's continue. Yeah, Bright Junior, you have access after the class. The video will definitely be there. Is that clear? Okay, so let's proceed to consider. I think we have looked at addition of complex numbers, equality of complex numbers. So let us consider subtraction of complex numbers, right? Let's consider subtraction of complex number. Subtraction of complex numbers. Okay? Yeah. Subtraction of complex numbers is if, for example, if Z1 equals to A plus IB and Z2 is equals to C plus ID, then we now say find Z2 minus Z1. Yeah. You don't need a prophet to tell you. This is a subtraction of complex number. Is that clear? So what you need to do here is write solution. Our Z is equals to A plus IB and Z2 is equals to C plus ID. Amen? Okay? So Z2 minus Z1 is equals to C plus ID minus, listen very carefully, minus, I want to do something, minus A plus IB. Yeah. Any question at this point? I know why I'm asking you. Any question at this point? Any question? I want a question from you guys. I want a question. I want a question from you guys. I want a question from you guys. I did not change anything. Look at the question. Abdul Kadir. They said Z2 minus Z1. I did not change it. Look at it. I'm going by the question. No. Look at the board very well. Z2. Look at it. This one minus 1, so it must be in this form. Is that clear? So now, I was expecting people to ask me a question. Why the brackets? The brackets means this minus affects what is here and what is here. But if now you now write it in this form, you remove the bracket. It means the bracket will affect only these real parts, and it does not affect the imaginary part. It means your answer might not be correct because of this sign. So you must put the brackets so that this negative sign will affect both the real part and imaginary part. That is the essence of this bracket. Take note. So here will now becomes C plus ID minus times A minus times plus IB minus IB. Can you see now? So now we collect like terms. So here will now be C minus A plus ID minus IB. So this is equal to C minus A plus I open bracket D minus B. This is the final answer. Any question, please? Do you have any question? Any question? Yes or no? Becky, why is A and C not together? Together, look at it now, look at the board. Look at the board. Okay, let's proceed. Let us proceed. Are you following? Let us proceed. Okay. That is that. So I want you guys to consider this coming. I want you guys to consider this problem. Okay. I want you guys to consider this problem. If Z1 is equals to 2 plus I and Z2 is equals to 4 minus 3I, find Z1 minus Z2. Yeah. 2 marks. The first 5 students that will solve it correct, 2 marks. You remind me in class. I give you only 2 minutes. Your time has started. This is 9:48. Your time has started. 2 minutes. Please write the answer in the comment section. 2 minutes. 2 marks. Solve it and write your answer in the comment section, please. Solve it and write your answer in the comment section. I'm waiting for you guys. Amen. Arthur Adams, 4 minus 2I. Salami, 4 minus 2I. Why is 2z coming before here? Somewhere it will be. You are asking me a question. I gave you a question. Joshua, 4 minus 2i, 3 persons have solved it. I don't know whether it is correct or wrong. Who else? Remaining 1 minute. Yusuf, 4 minus 1i, that is I. Okay, Jonathan, 4 minus 2i is okay. 1 minute left. 1 minute left. If I say stop, okay, time up. Time up, okay. Let's solve it together, whether you are right or wrong. Amen. Let's solve this together, whether you are right or wrong. Okay, right solution. So our z1 minus z2 is equals to 2 plus I minus open bracket 4 minus 3I. True or false? Because z1 minus z2. So here will now be equals to 2 plus I, open these brackets, minus 4 plus 3I. True or false? Amen? So far, so good. This is equals to correct like terms, 2 minus 4 plus I plus 3I. So far, so good. This is equals to minus 2 minus 4 is minus 2. Then I plus 3I is plus 4I. Okay? If you use minus to multiply this 2 minus 4I, but I will advise you to leave it like this, minus 2 and plus 4I. Okay? You try. Clap for yourself. Clap for yourself. Okay? You tried. Okay, so let's look at, we'll solve some problems from the past question. Is that clear? We'll solve some problems from the past question. So let us consider multiplication of complex numbers. Multiplication of complex numbers. Multiplication of complex numbers. Amen. That is if, for example, if z1 equals to a plus ib and z2 is equals to c plus id, then we will now say find z1 times z2. Whenever you come across something like this, it means multiplication. Is that clear? So what we need to do is we write solution. Our z1 times z2 is equals to a plus ib times c plus id. So let us multiply out a times c. We are going to have ac, then a times id. We are going to have plus iad, then ib times c plus ibc, true or false? Are you following? Then I times I. We are going to have plus I square b times d bd. True or false? Any question? Do you have any question? Gentlemen? Any question, yes or no? Any question? Any question? No question? So we can proceed, right? It's okay. So far, so good. So this implies that note I square is equals to minus 1. True or false? So this is equals to AC plus IAD plus IBC equals to minus 1 times BD is minus BD. Then we now collect like terms. So our AC minus BD plus IAD plus IBC. Amen? Are you following? Then this is equals to AC minus BD, then plus I open bracket AD plus BC. This is how you are going to solve this type of problem. Any question before we move to solve example from the past question? Any question at this point, please? I give you 1 minute to ask your question. 1 minute. I give you 1 minute to ask your question. No question? Yeah, I square is minus 1 now. I square, look at it. Look. I square is minus 1. Look at it. Oh, you want me to write it this way? Plus minus 1 times BD. Is it not the same thing? By the time you use this to multiply, here will be what? Minus now. 1 times BD. Is it not the same thing as minus BD? Okay, look at it. Minus 1 times BD. What are you supposed to get? Is it not minus BD? True or false? Minus BD. Okay. So let's proceed to solve an example from the past question. From the past questions. Okay. Given Z1 equals to 2 plus 3i, 2 plus 3i, and Z2 equals to 3 minus 2i, 3 minus 2i. Determine Z1 times Z2. Yeah, it's simple as ABC. Let us consider this. Let's write solution. So our Z1 times Z2 is equals to 2 plus 3i times 3 minus 2i. True or false? Okay? So let's multiply out 2 times 3, 6, right? Then 2 times minus 2i minus 4i. Amen? Okay? Plus 3i times 3 plus 9i. And plus 3i times minus 2i, we are going to have minus 6i all in square. True or false? Any question before we proceed? Please, do you have any question? Do you have any question? Any question? Any question? No question? No question. Okay, let us proceed further. There is no question. So this is equals to okay. Note that I square is equals to minus 1. True or false? So far so good. This is 6 minus 4i plus 9i minus 6 open bracket minus 1, right? Okay, so as you can see, this is 6 minus 4i plus 9i. You are supposed to have plus 5i. True or false? It's true. Then minus 6 times minus 1 plus 6. So you can now see that we collect like terms 6 plus 6 plus 5i. 6 plus 6 will give you what? 12 plus 5i. This is the final answer. Any question, please? This question is from past question. If you check your past questions, you may see questions like this. Any question, please? Do you have any question? How to get minus 1? Minus 1. Rabiu Yusuf, I know you are just coming. That is why you are asking this question. Minus 1. I stated it there now. Note that I square is equals to minus 1. So you see that in the expression we have 6 minus 4i plus 9i minus 6i square. So in place of I square, you write minus 1. Look at it very well. Rabiu. Ali. Saruma. Ali. I know you are just coming. Amen. Jubiri. You are also. Okay. So that is that. Let's consider another example. Let's consider another example. Simple as APC. Let's consider another example. The example says okay, another example says if Z1 equals to minus 2 plus 4i minus 2 plus 4i and z3 equals to square root of 3 minus 2 square root of 3 minus 2i. And express express 18z1, amen, plus 3z2 square, 3z2 square, then plus 3z3 plus 3z3. Okay, yeah, it's simple as ABC. Is that clear? Very simple. Simple as ABC. Okay. Yeah. Let's begin to solve this. Let's solve this. It's very simple. What you need to do is just substitute in Z1, Z2, and Z3. Write solution. Okay. 18 open bracket 2 plus 2i plus 3 open bracket z minus 2 plus 4i z2 is squared, right? You square it, then plus 3 open bracket z3 is root 3 minus 2i. Amen? Any question? Do you have any question? Do you have any question? Yes or no? Bright Junior. Okay? So 18 times 2, 36, right? 18 times 2i plus 36i, two of us. Then here, plus 3 first. If we have minus 2 plus 4i all in square, this is the same thing as minus 2 plus 4i times minus 2 plus 4i, right? Two of us. So minus 2 times minus 2, we are supposed to have plus 4. Minus 2 times plus 4i minus 8i, two of us. Then plus 4i times minus 2 minus 8i. Then plus 4i times plus 4i, you have plus 16i squared. Then your I square is always known as minus 1, right? So here is 4 minus 8i minus 8i. We are supposed to have what? Minus 16i, then plus 16 open bracket minus 1, because I square is minus 1. Two of us. So here we are going to have 4 minus 16i minus 16. Then when we collect like terms, we are supposed to have minus 12 minus 16i. Two of us. This will give us this answer. So here is supposed to be 12 minus proceed further. Do you have any question? Do you have any question? Any question? Yes or no? No question. How do we get the 12? Okay. Yeah. Look at it now. Look here. This is real. This is real. This is real part. This is real part. True or false? This is imaginary part. So let's do it this way. We correct like terms. It means 4 minus 16 minus 16i. Minus 4. 4 minus 16. Is it not minus 12? Minus 12 minus 16i. Do you understand? Are you following? Do you understand? Okay. So far, so good. So here, open this bracket, you have 3 root 3. This times this, you are going to have minus 6i, right? So there will be 36 plus 36i. 3 times 12, what you're supposed to have is 36, right? Then minus 3 times 16i is 48i, right? Minus 48i. 48i. Then plus 3 root 3 minus 6i. True or false? Any question? Any question? Why is 16 carrying square? 16 is not carrying square. It's 16i square. I square, please. 16 does not carry square. Sir, the 36 is supposed to be minus 36. Which one? Why? Huh? Why? Becky? Becky, why? Becky, why? Why? Is minus 12 minus 16i now? Is minus 12 minus 16i. Minus 12 minus 16i. Okay, let's proceed. Let us proceed to, we collect like terms. Here we have 36 plus 36, then plus 3 root 3, then plus 36i minus 48i, okay, minus 6i. Is that clear? Okay. So as you can see now, this one plus this is going to give us what? 72, right? 72 plus 3 root 3, you leave it like this, you cannot add this. Then I want you to add or subtract this. and give me the answer. True or false? Am I right? Yeah. Any question? So we can proceed, right? So this is how you are supposed to break it down. So let us proceed to consider okay, Jonathan, can we write the root of 3 as a power of 1 all over 2 joined together? Except you want to write it this way now. 72 plus 3, open bracket. 3 raised to the power of 1 all over 2 minus 18i. No problem. If you want to transform it in this form, you don't have problem. Is that clear? Okay. So let's proceed to consider division. Division of complex numbers. Since there is no question. Bright Junior, yes sir. The minus 16i. You don't understand why it is squared. Bright Junior, you are not lost. After the class, take your time to go back to the video again. You are not lost. Okay. So let's proceed to consider hope you people are copying this note down. Division of complex numbers. Division of complex numbers. When we say division, you know it. If we have something of this form, this is known as division. If we have Z1 all over Z2, this is also known as what? Division. Is that clear? So what we need to do here is we are going to consider example so that you always find it easy. So let's look at one example. If Z1 is equals to A plus IB and Z2 is equals to C plus ID, and it says find Z1 all over Z2. Amen? Okay, so let's look at it together. Z1 all over Z2 now be equals to A plus IB all over C plus ID. So when you come across something of this form in complex number, as long as the denominator is complex number, you are going to do what is called conjugates. I hope you were taught in algebra, elementary algebra, how to conjugate a given expression. So what we need to do here is this will now be equals to, and this is equals to a plus ib all over c plus id, c plus id times, you conjugate the denominator, times c, this plus will now turn to what? Minus id all over c minus id. Are you following? Any question, please? Any question? Any question? Do you have any question? Yes or no? No question? Okay, let me proceed. So far so good. So our z1 all over z2 will now be equals to a times c, ac, a times minus id, going to give you minus iad, then plus ib times c plus ibc. Hope you are following. Then I plus ib times minus id minus I square bd. Amen. Then all over the same way, c times c, c square, c times minus id minus icd. Then plus id times c plus icd. Then plus id times minus id minus I square, then d square. True or false? Do you have any question here at this point before I proceed? Please, any question, drop it in the comment section. Any question? Do you have any question? Yes or no? Yes or no? No question? You are not saying. Becky, you don't understand. You don't know how to multiply. That is what I'm trying to say. Is this. When you have a plus ib all over c plus id, you discover that this is complex number. This is complex number. So both of them are dividing each side. So the best way to approach this type of question is for you to conjugate the denominator. Since the denominator here we have c plus id, right? So use it to multiply both top and bottom of the right hand side. So then the sign, what is here? Here is plus. So this plus will now turn to minus. That's why you are saying c minus id all over c minus id. Then you multiply, just like this is how it is, times c minus id all over c minus id. You multiply, use the numerator to multiply the numerator, use the denominator to multiply the denominator. Then you arrive at this answer. Okay? So let's proceed. This is equals to, mind you, I square is equals to minus 1. So minus AC minus IAD plus I BC. So here we now minus open bracket minus 1 BD all over. Then C square minus ICD plus ICD. Then minus open bracket 1 times D square. Look at the denominator. This and this will cancel. Two of us. This is negative, this is positive. They are the same thing. So here will now be AC minus minus IAD plus IBC minus times minus plus 1 times BD going to give plus BD all over C square minus times minus plus 1 times D square plus D square. Yeah. So finally you take the real to be on one side, then imaginary will be another side. So here will be AC plus BD. Then let's bring this one first. Excuse me, before the minus, or whichever we want to do it, plus IBC minus IAD all over C square plus D square. I think you can stop here, whichever way. Any question? Any question? Yes or no? Do you have any question? If there is no question, let's solve from the past question. Let's solve from the past question. I think we have past questions. Let us solve from the past questions. Okay. Let's solve from the past question. Evaluate evaluate 2I all over minus 1 plus I. Yeah, let's look at this problem. It's simple as ABC. So what you need to do, we write solution 3 minus 2I all over minus 1 plus I is equals to, you conjugate the denominator. So our 3 minus 2I all over minus 1 plus I. The conjugate is going to be on the imaginary part. In front of the imaginary part, the operation here is plus. So it will turn to what? Minus. So don't bother about this one here. Is that clear? So this is what you are going to do, times minus 1 minus I all over minus 1 minus I. So you can now see that this is 3 minus 2I all over minus 1 plus I, close bracket, times minus 1 minus I all over minus 1 minus I, close brackets. Amen? So, the next thing we are going to do is use this to multiply this 3 times minus 1. We are going to have minus 3. 3 times minus I minus 3I, and minus 2I times minus 1 plus 2I, minus 2I times minus 2I plus 2I squared. True or false? That is the numerator, all over minus 1 times minus 1 plus 1, minus 1 times minus I plus I, then plus I times minus 1 minus I, then plus I times minus I is minus I squared. Any question before I proceed? Please drop it in the comment section. Any question? Do you have any question before I proceed? Any question? No question? Okay. Let's proceed. Let us proceed. So here, our I squared is minus 1. So minus 3I plus 3I, we are going to have minus I plus 2 open bracket minus 1, then all over, look at it, minus I minus I. So this and this will cancel. Then here we are going to have 1 minus I squared. Then this is equals to minus 3 minus I minus times plus 2 times minus. What you're supposed to have is minus 2 all over 1 minus I squared is minus 1, isn't it? So this is equals to, we collect like terms, minus 3 minus 2 minus I all over 1 minus I times minus is plus 1, which is equals to minus 3 minus 2. We are going to have minus 5 minus I all over this plus this. 1 plus 1, 2. Therefore, this is equals to minus 5 all over 2, then minus I all over 2. Any question? Any question, please? Do you have any question? Do you have any question, gentlemen and ladies? Yes or no? Any question? No question? Okay, let's solve one problem, then we call it a day from the past question. From the past question, let us solve one problem. Then we call it a day. Okay? Is that clear? Okay. Let's solve one problem. If Z1 equals to 3 plus 2I, then 2 plus 3I. 2 plus 3I, and Z2 is equals to, Z2 is equals to 3 minus 2I. Determine Z1, think so, Z1 all over Z2. Amen. This is from past question. So let's solve it together. Let us solve it together. So far so good. Z minus Z1, sorry, 1 minus Z1 all over Z2 will now be equals to 1 minus Z1 is open bracket 2 plus 3i, and all over Z2 is 3 minus 2i, right? So far so good. What we do? We open this bracket, 1 minus 2 minus 3i, all over 3 minus 2i. Note that there is an invisible one, so we have to take the LCM. So the LCM will now be 1 and 3 minus 3i, true or false. So we are going to have 1 open bracket, 3 minus 2i, amen. Hope you are following. Then minus 1 open bracket, 2 minus 3i, then all over the LCM 1 times 3 minus 2i, sorry, is the same thing as 3 minus 2i. True or false? It's true. Okay? So far, so good. So what we need to do here is we open the bracket. This 1 times this, we are going to have 1 times 3 is 3. 1 times minus 2i minus 2i. Minus 1 times 2 minus 2. Minus 1 times minus 3i plus 3i. Then all over 3 minus 2i. True or false? It's true. Then we collect like terms. So this will now be 3 minus 2, then minus 2i plus 3i all over 3 minus 2i. True or false? It's true. Right? So 3 minus 2 is 1, right? This is equals to 1. Then minus 2i plus 3i is plus i. Plus I all over 3 minus 2i. Yeah, guess what? This is not the final answer. Is that clear? This is not the final answer. Why? Because complex numbers, this is a complex number, this is a complex number, dividing each other. So you have to apply conjugates. Is that clear? To get the final answer. Are you following? I don't know whether there is question here. Ask your question. I give you 1 minute to ask your question. If there is any question, sir, is that the final answer? It can never be the final answer. We have to conjugate. MPRE 020, you are just coming. Why? So we have to conjugate. So let us conjugate this problem. Okay. So we now have this will now be equals to 1 plus I all over 3 minus 2I times, you can now see that this is minus, so we'll turn into what? Plus 2I all over 3 plus 2I. So this will now be equals to 1 times 3 is 3, 1 times 2I plus 2I, I times 3 is plus 3I, then I times 2I is plus 2I squared, right? All over 3 times 3, we are going to have 9, then 3 times plus 3I, we'll have plus 6I, true or false? Then minus 2I times 3 minus 6I, then minus 2i times plus 2i, we are going to have minus 4i squared, right? So denominator, this and this will go. We had this to give us 3 plus 5i, then plus 2. Note that I squared is always minus what? 1. So minus 1 all over 9 minus 4. I squared is always minus 1. Okay? So if you can see what I'm saying, this is equals to 3 plus 5i plus 2 times minus 1 is minus 2 all over minus 4 times minus 1, I'm going to have plus 4. So you can now see that we collect like terms, 3 minus 2 plus 5i all over 9 plus 4 is 13, right? Then this is equals to 3 minus 2, 1. So 1 plus 5i all over 13. Oh, sorry about that. NEPA has taken the lights. So we are going to call it a day. Thank you and God bless you all.